Weekly Artificial Intelligence News. Hello viewers! Welcome back to your one-stop shop for all news AI. We're back once more with the latest, sometimes shocking happenings of the artificial intelligence universe. From spooky action being able to boost quantum machine learning, SCT helping the IoT, Graphcore speeding up AI, all the way to Yann LeCun thinking AI doesn't need our supervision, using real data to train AI, and brain-inspired chips, we have it all and more. So, without further ado, let's jump right into our weekly updates. However, before we do, we request you to subscribe to our channel and press the bell icon to never miss another upload of ours. Having said that, let's get right to it. Highlights of the week. Spooky action could help boost quantum machine learning. Machine learning, which now powers speech recognition, computer vision, and more, could prove even more powerful when run on quantum computers. Now, scientists find the strange quantum phenomenon known as entanglement, which Einstein dubbed spooky action at a distance, might help remove a major potential roadblock to implementing quantum machine learning, a new study finds. Quantum computers can theoretically prove more powerful than any conventional computer on a number of tasks, such as finding a number's prime factors. The mathematical foundation of the modern encryption currently protects banking and other secure data. The more components known as qubits that are linked together in a quantum computer through entanglement, wherein multiple particles can influence each other instantaneously regardless of how far apart they are, the greater its computational power can grow in an exponential fashion. Machine learning, which now powers speech recognition, computer vision, and more, could prove even more powerful when run on quantum computers. Scientists are still researching the specific problems for which quantum computing might have an advantage over classical computing. Recently, they have begun exploring whether quantum computing might help boost machine learning, the field of AI that investigates algorithms that improve automatically through experience. Standard certification testing, the Internet of Things. From human speech to quantum encryption, communication relies on protocols that are mutually understood and reliably implemented. Without them, there is only noise. In the world of electronic communications, standard certification makes sure that everybody knows the rules and plays by them. Comarch, the $500 million IT company with headquarters in Kraków, Poland, and offices in 100 countries, is playing a leading role in developing automated standard certification systems. In 2007, Comarch began working with the UPnP Forum, now part of the Open Connectivity Foundation, to certify universal plug-and-play compliance for personal computers, Wi-Fi access points, routers, audio-visual, and other devices on home-scale networks. Over the years, Comarch has steadily expanded its work with multiple standards organizations. In October 2021, when the AVNU Alliance debuted its test tool for the Milan Advanced Certification Program for time-sensitive networks, Comarch distilled 15 years of automated certification testing into its new Comarch Automated Testing Framework to make it happen. Thanks to CATF, AVNU could promise its members faster, easier, more convenient, and less expensive testing that would guarantee performance and interoperability of high-speed devices for audiovisual, automotive, and industrial applications. Applications that demand security, reliability, efficient use of available bandwidth, adaptation to varying latency, and ultra-precise timing. Graphcore uses chip tech to speed AI by 40%. UK-based AI computer company Graphcore made a significant boost to its computer's performance without changing much of anything about its specialized AI processor cores. The secret was to use TSMC's wafer-on-wafer 3D integration technology during manufacture to attach a power delivery chip to Graphcore's AI processor. The new combined chip, called Bow, for a district in London, is the first on the market to use wafer-on-wafer bonding, say Graphcore executives. The addition of the power delivery silicon means Bow can run faster, 1.85 GHz versus 1.35 GHz, and at lower voltage than its predecessor. That translates to computers that train neural nets up to 40% faster with as much as 16% less energy compared to its previous generation. Importantly, users get this improvement with no change to their software at all. Yann LeCun. AI doesn't need our supervision. When Yann LeCun gives talks, He's apt to include a slide showing a famous painting of a scene from the French Revolution. Superimposed over a battle scene are these words: "The revolution will not be supervised." LeCun, VP and Chief AI Scientist of Meta, formerly Facebook, believes that the next AI revolution will come about when AI systems no longer require supervised learning. No longer will they rely on carefully labeled datasets that provide ground truth in order for them to gain an understanding of the world and perform their assigned tasks. AI systems need to be able to learn from the world with minimal help from humans, LeCun says. In an email, he talked about how self-supervised learning can create more robust AI systems imbued with common sense. He also explored this theme at the virtual Meta AI event titled Inside the Lab: Building for the Metaverse with AI. That event featured talks by Mark Zuckerberg, a handful of Meta's AI scientists, and a discussion between LeCun and Yoshua Bengio about the path to human-level AI. Still using real data to train your AI? It may sound counterintuitive, but some argue that the key to training AI systems that must work in messy real-world environments, such as self-driving cars and warehouse robots, is not, in fact, real-world data. Instead, some say synthetic data is what will unlock the true potential of AI. Synthetic data is generated instead of collected, and the consultancy Gartner has estimated that 60% of data used to train AI systems will be synthetic. But its use is controversial, as questions remain about whether synthetic data can accurately mirror real-world data and prepare AI systems for real-world situations. NVIDIA has embraced the synthetic data trend and is striving to be a leader in the young industry. In November, NVIDIA founder and CEO Jensen Huang announced the launch of the Omniverse Replicator, which NVIDIA describes as an engine for generating synthetic data with ground truth for training AI networks. Brain-inspired chips for good for more than AI. Brain-inspired neuromorphic microchips from IBM and Intel might be good for more than just artificial intelligence. They may also prove ideal for a class of computations useful in a broad range of applications, including analysis of medical X-rays and financial economics, a new study finds. Scientists have long sought to mimic how the brain works using software programs known as neural networks and hardware known as neuromorphic chips. So far, neuromorphic computing was mostly focused on implementing neural networks. It was unclear whether this hardware might prove useful beyond AI applications. Neuromorphic chips typically imitate the workings of neurons in a number of different ways, such as running many computations in parallel. In addition, just as biological neurons both compute and store data, neuromorphic hardware often seeks to unite processors and memory, potentially reducing the energy and time that conventional computers lose in shuttling data between those components. Furthermore, whereas conventional microchips use clock signals fired at regular intervals to coordinate the actions of circuits, the activity in neuromorphic architecture often acts in a spiking manner, triggered only when an electrical charge reaches a specific value, much like what happens in brains like ours. Until now, the main advantage envisioned with neuromorphic computing to date was in power efficiency. Features such as spiking and the uniting of memory and processing resulted in IBM's True North chip, which boasted a power density 4 orders of magnitude lower than conventional microprocessors of its time. We know from a lot of studies that neuromorphic computing is going to have power efficiency advantages, but in practice, people won't care about power savings if it means you go a lot slower, says study senior author James Bradley Amon, a theoretical neuroscientist at Sandia National Laboratories in Albuquerque. With that, we come to the end of this video. Consider subscribing to join in next time for more of such interesting content.